So, good morning, dear students. Myself, Dr. Lingaraju, Assistant Professor of Physics, Government First Degree College, Tumkur. So, previous we discussed diffraction and also types of diffractions and also the variants of knowing all these theory concepts. So, in this diffraction chapter, we have some simple problems. So these problems also having a 5 marks in exam. They are all easy problems with a simple formulas, and also you can get the full marks. So please concentrate, especially in problems, numerical problems. Okay. Now, today what here we are going to do is discuss the problems is comes under the diffraction chapter in a BSc Physics 4th sem. So it is comes under a session 35. Okay. First we will discuss the first problem. First problem is so here first we have to understand the problem. If we can understand the problems means so we can get the ideas about what formula we require. So then what are the points, what are the given points they are given data. So first we have to write it. Knowing the given data, using a basic knowledge about a particular subject, so we can easily get the idea about what formula we required. So knowing the formula, so just substitute the values and calculate. So this is the way here we can solve the problems. So like here we come to the first problem. You see, first I will read a complete problem, then I will give a given data and also required formula. You see, a parallel beam of light of wavelength 589.3 nanometer. So nanometer means 10 to the power of minus 9. N means 10 to the power of minus 9 meter. So here the parallel beam of light is having a certain amount of wavelength, that is a 589.3 nanometer. Falls on the cardboard. Provided with a fine hole. It is received on a screen at a distance of 0.5 meter from the cardboard. So calculate the radius of the hole if the intensity of a light on the screen is 4 times the intensity of the absence on the hole. So we can easily understand this problem. Here one light radiation will be comes out from the receiver and it is going to fall on one cardboard. That radiation is having a certain amount of radiation intensity, that is 589.3. So it is going to pass through one fine hole. So the point is how much the hole having a radius if they having a certain amount of intensities. That is the question. Since the intensity at the screen is 4 times in the absence of the hole. In theory we are already discussed. So the radius of the hole is equal to that of the first half period zone. The radius of the hole is equal to that of the first half period zone. So after knowing this one, what are the data they are given here? First is, so the wavelength is given, lambda is equal to 583.3 and also the distance. The distance is given, that is d is equal to b is there, so d distance, screen distance, it is used on the distance, it is received on the screen kept at a 0.5 d. So find the radius r. And now we know that r is equal to square root of b into lambda. On substituting the given value, we arrive the required answer. So r is equal to 5.4 into the minus 4 meter. You see how the form is. It is a very simple problem. So 5 marks. If you know the theory concepts of this problem, so we can easily calculate. What they are given here? Only the distance. If knowing the distance, we can calculate the radius of the hole. The formula is given there already using a zone plate. Knowing the zone plate, we can calculate it. So it's about. Next is second one. Calculate the radius of the 10th zone in the zone plate of focal length 0.2 meter for a light of wavelength 6000 angstrom. You see, it is also very simple. We calculate the radius of the 10th zone. So in the circle, so we are going to observe it. That is the 10th line, the 10th zone. On the zone plate, in a one zone plate, of a focal length is 0.2 meter for a light of wavelength 6000 angstrom. ಏನೇನು ಕೊಟ್ಟಿದ್ದಾರಲ್ಲಿ n is given, that is a 10. ಅಂದರೆ 10th zone plate n. Lambda means just intensity of radiation will be comes out having a wavelength lambda, that is 6000 angstrom. It is there given in a SI, that is 10 to the power of minus 10. Then, so there is also we can write it as in the form of nanometer, 16 to the power of minus 7 nanometer. So sorry, meter. 6 into 10 to the power of minus 7 meter. So yeah, focal length, that is a 0.2. So the meter, that is also they are given in SI unit. So we know that the formula R n, nth value. So Rn is equal to square root of n lambda f. So substitute all the values to find Rn. And substitute the given data in Rn formula, we arrive at the required answer. So Rn is equal to square root of n is equal to 10. N into, it means 10 into 6000 into the power minus 10 into 0.2. So we are getting a 1.095 into the power of minus 3 meter. So it's about the second problem. So it is also a very easy problem. Next year we come to the third problem. 50 zones are marked on a zone plate. ಈಗ ಲಾಸ್ಟ್ ಕ್ಲಾಸಲ್ಲಿ ಲಾಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಏನು ಅಂದರೆ 10 zones ಅಂತ 10th zone ಕಂಡುಹಿಡಿದ್ವಿ. ಸೊ ಲೈಕ್ ದಟ್ ಇಯರ್ 50 zonesನ ದೇ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಡ್ರಾ ಮಾರ್ಕ್ಡ್. 50 zones are marked on a zone plate which has a diameter of 1 centimeter. 50 zones are marked on the zone plate which has a diameter of 1 centimeter. Calculate the focal length for light of wavelength 580 nanometer. In question once again we will discuss. 50 zones are masked on the zone plate. 50 zones, circles, 1, second zone, third zone, fourth zone, like that. So 50 zones are marked in the, which has a diameter of 1 centimeter. 1 centimeter diameter over. So 50 zones mark ಮಾಡಿದ್ದಾರೆ. Calculate the focal length of light of wavelength 580. So focal length ಕಂಡುಹಿಡಿಯಬೇಕು. So ಏನೇನು ಕೊಟ್ಟಿದ್ದಾರೆ 50 zones, n is equal to 50. So diameter d is equal to 1 centimeter. So focal length 580. On substituting Rn square by n lambda. So Rn square by n lambda. N is equal to 50. Lambda is equal to 580. R means radius. They are given the diameter 1 centimeter divided by 2. It becomes 0.5 into the power of minus 2 meter whole square. Substituting all these things, or substituting the given values, we arrive the answer is 0.86 meter. So it is also a very simple problem. So you can easily get it the answers. Next is, so fourth problem. We come to the fourth problem. A narrow slit illuminated with microchromatic light of wavelength 5893 10 to the power of minus 3. Maybe it is monochromatic, not a micro, it is monochromatic. A narrow slit illuminated with a monochromatic light of wavelength 5893 10 to the power of minus 10 meter is placed at a distance of 0.1 meter from the straight edge. If the distance between the straight edge and the screen is 1.9 meter, 1.9 meter, so B is 9 meter, 1.9 meter. Calculate the distance between the first and fourth dark bands for the fourth dark bands. It is very simple concept. As like a Newton's experiment. A narrow slit is illuminated in a monochromatic light of wavelength 5893 it placed in a distance of 0.1 meter at a straight edge. If the distance between the straight edge and the screen is 1.9 meter, calculate the distance between the first and the fourth dark bands in the circles. So lambda is equal to 5893 to the power of minus 10 meter. A is equal to 0.1 meter. M is equal to 0.1 meter. B is equal to 1.9 meter. For the first dark band, we know that xn is equal to square root of 2n of a plus b into lambda by a. So substitute the values. N means 1 here first. So substitute the given values of x1 is arrives. So substituting a2 into n is equal to 1, a and b. A is 0.1, b means 1.9 of 1.9 into lambda, 3 is 5893 to the power of minus 10 divided by 0.1. So with the square root. Substituting all these values, so we are getting a x1, that means n1, that is equal to a first dark band 6.69 into the power of minus 3 meter. Next, the second one is fourth dark band. The same formula, so we have to substitute in the previous concept. Instead of n1, 4 we have to substitute. On substituting the given value of x 4, we arrive at the required answers. X to the power of 4 is equal to 13.38 into the power of minus 3 meter. Hence, the distance between the first and fourth dark band is x to the power of 4, sorry, x4 minus x1. So, difference of this one is 6.67 into the power of minus 3 meter. It's about a fourth problems. Okay. Next, here we come to the fifth problem. So calculate the highest order spectrum of normal incidence. Calculate the highest order spectrum of normal incidence which may be seen with monochromatic light of wavelength 6000 10 to the power of minus m meter or angstrom by means of diffraction grating having a 6 into 10 to the power of 5 lines per meter. So here you see, calculate the highest order spectrum. First order, second order, third order, fourth order. So which one is at that particular pattern will be obtained. That is the highest order of a normal incidence, which may be seen with a monochromatic light of wavelength. This one, that is 6000 angstrom. By means of diffraction grating is, so in a given grating plate, 6 into 10 to the power of 5 lines per meter. And now lambda is given, that is how much? 6000. 6000 into 10 to the power of minus 10 meter. Find n. N value now ಕಂಡುಹಿಡಿಯಬೇಕಾರದು. So ಯಾವ ಆರ್ಡರ್ n is equal to question mark. Next, diffraction grating value ಕೊಟ್ಟಿದ್ದಾರೆ. So and also yes, okay. Next, we know that the formula n lambda is equal to sin theta n of a plus b. The maximum value of theta n is equal to 1. The maximum value of theta n is equal to 1. Hence, a plus b is equal to n lambda. Theta n 1 ಆಯ್ತಂದ್ರೆ a plus b is equal to n lambda. So now by grating diffraction grating, but diffraction grating a plus b is equal to 1 by 6 into 10 to the power of 5 meter. So knowing this concept, so next substitute the values of a given equations. N is equal to 1 by 36 into 10 to the power of minus 2 meter. N is equal to 1 by 36 into 10 to the power of minus 2 meter. That is equal to 2.77. That is equal to 2.77. Hence, the highest order of the spectrum that can be seen, n is equal to 3. Highest order of the spectrum, that is 2.77, we can say approximate value, that is n is equal to 3. So it's about the way of calculating the order of the spectrums using a diffraction spectrum, using a diffraction spectrum grating order. Okay, next problem number 6. A plane transmission grating having 6,000 lines per centimeter. You know, a plane transmission grating having a 6,000 lines per centimeter. Yeah, so ನಿಮಗೆ ಗ್ರೇಟಿಂಗ್ ಪ್ಲೇಟ್ ಅಂತ ನಾವು ಸೆಕೆಂಡ್ ಇಯರ್ಲಿ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡಿಸೋ ಟೈಮ್ ಒಳಗಡೆ ಗ್ರೇಟಿಂಗ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡುವಾಗ ನೋಡಿದ್ದೀರ. ಯು ಆರ್ ಆಲ್ರೆಡಿ ಸೀನ್ ಗ್ರೇಟಿಂಗ್ ಪ್ಲೇಟ್. So they having a 6,000 lines per centimeter. In the one glass plate per centimeter they have drawn 6,000 lines. Just you imagine it. How they have it. ಅಷ್ಟು ಲೈನ್ ಅವ್ರು ಡ್ರಾ ಮಾಡಿರ್ತಾರೆ 1 ಸೆಂಟಿಮೀಟರ್ ಒಳಗೆ. ದಟ್ ಒನ್ ಈಸ್ 5,000 ಲೈನ್ಸ್ ಪರ್ ಸೆಂಟಿಮೀಟರ್. ಅದರ ಎಷ್ಟು ಲೈನ್ ಎಳೆದಿರ್ತಾರೆ ಅದರ ಮೇಲೆ ಅದನ್ನು ಗ್ರೇಟಿಂಗ್ ಕಾನ್ಸ್ಟೆಂಟ್ ವ್ಯಾಲ್ಯೂನ ಡಿಫೈನ್ ಮಾಡೋದಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ಕೊತಾರೆ. ಸೊ 5,000 ಲೈನ್ಸ್ ಪರ್ ಸೆಂಟಿಮೀಟರ್ ಈಸ್ ಯೂಸ್ಡ್ ಟು obtain a spectrum of light from a sodium lamp in the second order. Calculate the angular separation between the two sodium lines whose wavelength are 5890 angstrom and 5896 angstrom. So solution. We know that a plus b is equal to 1 by 5 into 10 to the power 5 meter. So here ಏನೇನು ಕೊಟ್ಟಿದ್ದಾರೆ ಅವರು ಲ್ಯಾಂಬ್ಡಾ 1 ಲ್ಯಾಂಬ್ಡಾ ಕೊಟ್ಟಿದ್ದಾರೆ. ದಟ್ ಈಸ್ ಲ್ಯಾಂಬ್ಡಾ 2 ಲ್ಯಾಂಬ್ಡಾ ಇದಾವಲ್ಲ. ಸೊ ಹಂಗಾಗಿ ಲ್ಯಾಂಬ್ಡಾ 1 5890 ಅಥವಾ 589 into the power -7. ಲ್ಯಾಂಬ್ಡಾ 2 ನ 5.896 into the power -7 meter. Okay. So to find the angular separation, that is theta 2 minus theta 1 ಎಷ್ಟಿದೆ ಅಷ್ಟು ನೋಡಬೇಕಾಗಿದೆ ನಾವೀಗ ಅಲ್ವಾ. ಸೊ ಈಗ ಫಸ್ಟ್ ಎರಡನೇದಕ್ಕೆ ಬರೋಣ. ಸಾರಿ ಸೆಕೆಂಡ್ ಆರ್ಡರ್ n is equal to 2. ಏನು ಫಾರ್ಮುಲಾ ವಿ ನೋ ಆಲ್ರೆಡಿ. a plus b of sin theta 1 is equal to 2 lambda 1. a plus b of sin theta 2 is equal to 2 lambda 2. Hence sin theta 1 is equal to 2 lambda 1 by a plus b. ಈಗ substitute the values. Lambda 1 ಅಂದ್ರೆ ಎಷ್ಟು 5890 into the power -7 divided by a plus b. The values you know it. Substituting the values of a plus b, so we are getting a 0.589. Or theta 1 is equal to 36 degree 4 minutes. Similarly, sin theta 2 is equal to 0.5896 or theta 2 is equal to 36 degree 8 minutes. So therefore, on taking the difference and angles, we arrive at required answer. You know, the angular separation theta 2 minus theta 1 is equal to 4 minutes of an arc. 4 minutes of an arc. 36 minute 36 8 minute 36 4 minute ಹೋದರೆ our next ನೋಡ್ಕೊಳ್ಳೋದು ಎಷ್ಟು 4 minutes of an arc in this angle. Here we are going to calculate it. So it's about this problem. Next is 7th problem. Light. A light of wavelength 5000 angstrom is incident normally on a slit. ಒಂದು ವೇವ್ಲೆಂತ್ 5000 ಇರೋಂಥ ಲೈಟ್ ಸೊ ಸ್ಲಿಟ್ ಮೇಲೆ ಬಿತ್ತು. ದ ಫಸ್ಟ್ ಮಿನಿಮಮ್ ಆಫ್ ಎ ಡಿಫ್ರಾಕ್ಷನ್ ಪ್ಯಾಟರ್ನ್ ಈಸ್ ಅಬ್ಸರ್ವ್ಡ್ ಟು ಲೈ ಅಟ್ ಎ ಡಿಸ್ಟೆನ್ಸ್ ಆಫ್ 5 millimeter. ಸೊ ದ ಫಸ್ಟ್ ಮಿನಿಮಮ್ ಆಫ್ ಎ ಡಿಫ್ರಾಕ್ಷನ್ ಪ್ಯಾಟರ್ನ್ ಈಸ್ ಅಬ್ಸರ್ವ್ಡ್ ಟು ಲೈ ಅಟ್ ದ ಡಿಸ್ಟೆನ್ಸ್ ಆಫ್ 5 millimeter. ಫ್ರಮ್ ದಿ ಸೆಂಟ್ರಲ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಆನ್ ಎ ಸ್ಕ್ರೀನ್, ಫ್ರಮ್ ದಿ ಸೆಂಟ್ರಲ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಆನ್ ಎ ಸ್ಕ್ರೀನ್, ಪ್ಲೇಸ್ ಅಟ್ ಎ ಡಿಸ್ಟೆನ್ಸ್ ಆಫ್ 2 meter ಫ್ರಮ್ ಇಟ್. ಕ್ಯಾಲ್ಕುಲೇಟ್ ವಿಡ್ತ್ ಆಫ್ ದಿ ಸ್ಲಿಟ್. ಸೊ ಇಲ್ಲಿ ನೋಡಿ ಏನೇನು ಕೊಟ್ಟಿದ್ದಾರೆ ಡೇಟಾಸು. ಲ್ಯಾಂಬ್ಡಾ ಕೊಟ್ಟಿದ್ದಾರೆ ಎಷ್ಟು 5000 angstrom. ಸೊ ಆಮೇಲೆ ನೆಕ್ಸ್ಟ್ ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ ದ ಅಬ್ಸರ್ವ್ಡ್ ಡಿಸ್ಟೆನ್ಸ್ ಲೈ ಅಟ್ ದಿ ಡಿಸ್ಟೆನ್ಸ್ ದಟ್ ಈಸ್ y is equal to 5 millimeter. ಮಿಲಿಮೀಟರ್ 10⁻³ ಮೀಟರ್ ಅಂತ ಕರಿಬೇಕು. ನೆಕ್ಸ್ಟ್ ಎಲ್ಲಿ ಆ ಸ್ಕ್ರೀನ್ ಎಷ್ಟು ದೂರದಲ್ಲಿ ಇಟ್ಕೊಂಡಿದ್ದಾರೆ ದಟ್ ಈಸ್ ಡಿ is equal to 2 meter. ನಾವು ಕಂಡುಬೇಕಾದೇನು ಅಲ್ಲಿ ವಿಡ್ತ್ ಆಫ್ ದಿ ಸ್ಲಿಟ್ ಎ, ಸ್ಲಿಟ್ ವಿಡ್ತ್ ಕಂಡುಬೇಕು. ಸೊ ವಿ ನೋ sin theta is equal to lambda by a. So then the above equation sin theta is equal to lambda by a ಏನಾಗುತ್ತೆ theta is equal to lambda by a ಆಯಿತು. So y by d is equal to y by a. From the above equation ನಾವು ಕಂಡುಹಿಡಬೇಕಾದ ಸ್ಲಿಟ್ ಬಿಡ್ತೀವಿ. ಎ ಇಸ್ ಈಕ್ವಲ್ ಟು y by d into lambda. So on substituting, we arrive the equal answer is A is equal to 2 into 10 power of minus 4 meter. So it's about the 7th problem. So all these things, all these problems I have are referred in so many different referred publications. That is Subramaniam and also Sundararajan, and also 3 different authors written the books in using a Tumkur Literature Syllabus prescribed textbooks. So using these reference books and textbooks I have done. Thank you.